years, we have been bringing the aviation safety message to you via seminars, workshops, and videos using our aviation safety team representatives, which means our production crew is made up almost entirely of volunteers giving their time to support aviation safety. After today's presentation, would you please take minutes to take their time to thank our stage group, floor, and crew, camera crew for their time and efforts. Now, our next presenter is Van McKenny. Van works with the National Transportation Safety Board as an aerospace engineer and accident investigator. Let's welcome Van McKenny. Van? Welcome.
Thank you. All right, thank you. Okay, I don't know what the schedule shows right now. This may not be the one you're expecting. If you're expecting the presentation on self-locking nuts, that happened yesterday morning. I'm presenting today on cockpit object security and GA safety. This is my first time at Sun and Fun. I'm really kind of excited to be here. I've been out on the ramp looking around and seeing the airplanes, and it's really great and watching the air show. My background is a naval aviator, and I also worked at Johnson Space Center as an EVA operations engineer for the International Space Station, and I've been working with, been employed by the NTSB as an engineer and accident investigator for the last 11 years. Today I want to talk about cockpit object security and how some of these common objects that we take with us into the cockpit can end up causing us problems in flight. So as far as my topics go, I'm going to just do an overview of the NTSB. I think there's a lot of times, a lot of people I talk to aren't really clear about what the NTSB role is in government and how we relate with the FAA. And so I'm going to talk a little bit about that and our processes. Cockpit loose items safety alert. We have a safety alert, and that's going to be the focus of my talk today. We'll follow that up with some case studies showing some accidents related to the safety alert, and then I put together some lessons learned, some things we can do and think about when we get ready to go flying. All right, the NTSB's mission is to independently advance transportation safety, and we're mandated by Congress to do a number of things. First of all, we're mandated to be independent and objective, and the way we are independent and objective is we report directly to Congress, and we're not, the NTSB is not under any other of the departments, Department of Transportation or the FAA. We're independent, report directly to Congress, funded directly by Congress. This allows us to, during an investigation, if we need to investigate other aspects, regulatory aspects, we don't have a conflict of interest. I conduct objective, precise accident investigations and safety studies. That's what most of you are familiar with. One of the things that most people aren't familiar with is the role that we have with our branch of administrative law judges. And those judges perform airman and mariner certification appeals. So if a mariner or airman has a violation or gets in trouble with regulatory agencies, they can come to the administrative law judges and have that case looked at and judged from an independent point of view. So that's something most people aren't familiar with. And then we advocate promoting safety and recommendations. Of course, most people know safety recommendations are our main tool that we use to promote safety. And then the last thing that we're mandated to do is provide assisting victims of transportation accidents and their family. And we have a branch called the Transportation Disaster Assistance Group that is that intermediary between the investigation team and the family and the victims of family, the friends of the family. And that person facilitates a good two-way communication so that the investigation team can get the information they need about the pilots, the family, what was going on at the time of the accident on a personal level, get the materials they need, maybe pilot records or whatever, but also then they act as a conduit the other way, and let the families know what the investigation team is doing, what's the next steps, where the wreckage is located, what do they expect, when will the preliminary report be out, and they facilitate that communication. And it's been very, very good synergy with the investigation and with the people involved, directly involved with the accident. The safety board is structured with 5 board members, and these board members are presidentially appointed and approved by Congress, so by the Senate, confirmed by the Senate. They've served 5-year terms, and the center person there is the chairman. That's Chairman Hirschman. She's actually leaving the NTSB this month. Chairman Hart, who is this second on your left, excuse me. He's the vice chairman, and he'll be taking over the chairman responsibilities. And on your far right is member Earl Weiner, and I believe he's going to be speaking here at Sun and Fun on Saturday. Aspects of the NTSB, we're an independent federal agency, which I mentioned before. Staff is 420 people. We're one of the smallest agencies in the federal government, and that staff includes the entire investigative staff, the administrative staff, the managing staff, and the staff for the other modes of transportation. So we're not a big agency to do the work that we do. We're investigative and not regulatory, so we do not do any enforcement actions in relation to any of the investigations. We have nothing to do with that aspect of the government. We're strictly investigating accidents and looking for safety improvements. We're mandated to investigate every civil aviation accident in the U.S., and we also are appointed accredited representatives to foreign accidents, which brings us to about 1,400 accidents a year that we're participating in or investigating. That's just on the aviation side. And then on the other modes of transportation, which we're involved in, highway, pipeline, maritime, and rail, they respond to significant accidents in those modes as well. Aviation is about half our staff, and then the next largest mode of transportation is rail. So there's quite a few rail investigations going on at the time every year. We develop reports, outline facts, conditions, circumstances, which is most people are familiar with, and issue safety recommendations. We're divided into basically 3 regions in the country. The blue region there is the eastern region, the central region is in green, and the western region is in yellow. And each region has approximately 15 to 20 aviation investigators for each region. So if you happen to find yourself on the phone talking to a investigator, you're probably talking to one of the regional investigators right there in the area that you're at. Alaska, since it's geographically separated from the rest of the United States, we have 4 investigators up there, and we consider that their own region. It's a little bit of a unique situation up there. NTSB Products, most people are familiar with the Blue Cover Report. That report is that's the most substantial report that we produce, associated with a major accident and also associated with a board meeting where all 5 board members meet publicly and discuss the accident and determine the probable cause. Most of the general aviation accidents that we produce are done through a factual report and docket. And the factual report is written by the investigator who's investigating the accident, investigator in charge, and that person builds the docket. And the docket is simply all the materials that are used in the investigation that are collected. So the docket material things are like photographs, witness statements, records of conversations, maps, charts, sometimes there's audio tapes. All that material that's used to build the investigation is the docket, and those docket materials are publicly available through the website. So this is something that's kind of come out in the last 5 years, that you are now able to access the docket material as well as the investigative report on the web. The brief report is really the analysis. So if you want to read about an accident and you just kind of want to get a synopsis of what happened, you want to read the brief report. And the brief report is the analysis. It basically paints the pictures of what happened. So in there we've got the facts and circumstances of the accident, and then follow through with what we think happened, and at the end of that report is the probable cause. So that's your core snapshot of the investigation and what we think happened. In addition to those reports, we do special studies, and we look at, or we have in place probably a special study going on every year. And this year, right now, we're working on a special study involving agricultural operations, and that special study is in the process of being finalized, and expect that to come out later on this year. In the past years, we've had other special studies, such as the experimental amateur-built aircraft special study, which was done in 2012, airbag performance in general aviation, 2011, glass cockpit avionics in light aircraft in 2010, parachute jump operations in 2008, and emergency services operations in 2006. I was directly involved with the emergency services operations special study and HAMS special study in 2006, and that special study, I can attest to, has really been embraced by the HAMS community, and they have taken a lot of actions to improve safety and taken on board a lot of the recommendations, a lot of points made in that study, and that has really been beneficial for that community over the last 8 years. Public forums, kind of a lesser known NTSB procedure, but that's when the board members have a particular topic that they want to explore, and they'll invite people from industry, regulators, government, operators, manufacturers to come in and talk about a particular subject and explore it. And the idea is to gather information but also raise the public's knowledge of that particular issue that the NTSB board members think's important, and often it's like an emerging issue. Safety alerts. Safety alerts are kind of a new product. We've been really kind of putting those out last couple of years. They pinpoint a particular safety issue that we'd like to put a spotlight on, but we don't really have enough to get a full recommendation in there to make effective change, but we want to put it out there and have people be aware of the safety issue that we're looking at. And then, of course, safety recommendations is the main tool for NTSB as a result of NTSB investigation. And in the past, safety recommendations have often been targeted towards the regulatory agencies, but recently a lot of our recommendations are being directed at other agencies, such as local agencies, state agencies, operators, even groups, even like owner groups and stuff make recommendations. Professional groups make recommendations to those groups for change. So now let me get into the focus of what I'm here to really talk about, and that's the safety alert. And NTSB's definition of a safety alert is a brief information sheet that pinpoints a particular safety issue with supporting statistical and factual information. We try to make these safety alerts real easy to read. They're one page, front and back, synopsis of what the issue is, supporting facts, usually relating to accidents that involve the safety issue, and then things you can do to help prevent that. Here's a copy, or here's the front page of the safety alert that I'm going to talk about. All secure, all clear. What I'm focusing on here is items in the cockpit that have caused accidents, and so we want to emphasize keeping track of your cockpit items and securing them before you go flying. The problem: forgotten and unsecured items within aircraft can lead to accidents and incidents as they move during flight, and we've had a number of accidents associated with this, and the number of items people and pilots are bringing in the cockpit is increasing, especially with things such as cell phones, PDAs, tablets, personal locator beacons. These things, portable antennas, these things can tend, if keeping track of can tend to get lost in the airplane and then cause problems. So this whole safety alert and the safety idea for me germinated on April 8th, 2012 when I was sent to an accident in Salinas, California. It was an X-ray EA 300L accident. What you see there is not the accident aircraft, it's just a file photo of the extra 300L to get you, let you familiar with the airframe. This accident was a 2 fatal accident. The pilot was a commercial pilot, age 32, with 847 hours. He had civilian and tactical jet experience. In fact, he was just graduated from the Marine Corps' AV-8A Harrier training, so he was experienced with that. He was performing aerobatics with the passenger, and the witnesses report seeing the airplane simultaneously roll inverted, pitch down, and enter rapid descent into the ground from approximately 3,000 feet. So when I arrived on scene, this is what I found, and it may take you a few seconds to kind of get your orientation of what we're looking at here, but let me see if I move this. So here's, if you can see my pointer, what we see here is the airplane impacted the ground in a near vertical attitude, inverted. So here we are, we have the rudder, horizontal stabilizer, vertical stabilizer, some of these gray bars here that you see, that's the fuselage section. Here's the cockpit area, and you can see the landing gear here. The engine was buried about 4 feet into the ground, and these fragments, this debris here, forward field of view is wing panel segments and aileron pieces. So when I arrived on scene, I did my normal on-scene documentation as best I could, and then we gathered up the pieces and shipped them to a wreckage recovery facility where I could lay everything out. We could take a close look at things in better detail. And to kind of shorten up the story, I'm going to just tell you where we ended up focusing on. And we ended up focusing on the tail section here of the airplane, the horizontal stabilizer, elevator, and elevator bell crank area, circled in red there on the picture. So here's the tail section as we laid it out. It's up on some stands, and the circled area in red is where we're going to focus on. Right here, this is the aft spar, the horizontal stabilizer. This piece of wood here is the aft spar, the vertical stabilizer, and right behind this doubler is where we found what I'm going to show you here next. And we actually we're looking at the tail, not searching for anything in particular, but we were looking at an AD that just to confirm that an AD had been documented, had been done properly. And as we kind of dug around in there, ended up pulling out this little baby here. Now it's a portable antenna, and when I pulled that out, I was kind of surprised. You know, what's an antenna doing back here in the tail? I don't think we usually put antennas back here in this part of the tail. And then the other question was, well, we had moved the wreckage from the main crash site to the examination area. So in that movement, did this end up in the tail inadvertently? So, you know, how am I going to clear this up? Was this, basically the question was this there in the tail at the time of the accident? So I was able to review my on-scene photographs, and sure enough, I had taken a picture of the inside of the tail, and you can see right here the cable wrapped around the this is the elevator push-pull tube here, elevator bell crank here. Here's the cable of the portable antenna, and then it's sitting here behind this doubler. So on scene, this definitely was in the tail bell crank area. So looking at the antenna witness marks and examining the bell crank and some witness marks on the airframe, I was able to pretty much figure out exactly where that antenna was at the time of the impact with the terrain. And here it is would have been sitting right here blocking this is the elevator bell crank, this is the elevator push-pull tube. So did not totally restricted movement of the elevator. So I felt pretty good about that, identified the problem that most likely caused the crash. But then, you have to ask yourself the question, what was the antenna doing loose? Where did it come from? Did the pilot know about it before he went flying? So did more investigation on that and found out that the pilot had recently started a subscription to XM weather radio information. So and that this antenna is compatible with a Garmin GPS 396, and it would receive weather information so the pilot could use that for navigation and see current weather. I did not find a Garmin 396 in the wreckage. However, his partner, who's half owner of the airplane, said they did have a Garmin 396 they used for navigation, and in fact, we found a Garmin 396 in the pilot's personal effects that were left on the ground. So the pilot had been using this at some point during his flying, and he had been doing some cross-country flights before he took this aerobatic flight. So he had removed the Garmin 396 and left some of his personal effects on the ground before he went flying on this aerobatic flight, but apparently he missed this antenna. He misplaced it at some point during his recent cross-country flights, misplaced it, didn't keep track of it, and it ended up migrating to the tail and causing this accident. So that's the probable cause. Determined that this antenna migrated to the tail and caused the accident, and basically the pilot wasn't aware of where all his equipment was. So this made me think, okay, so this is a common item we bring in the cockpit with us. How many events do we have like this, and how many times a year do we have something that's in the cockpit, something that we do use regularly, end up causing an accident? So I did an NTSB database on a search for a search of foreign object damage as a cause or factor in an accident. And after filtering through a number of a few hundred accidents, came out with about 19 accidents that were directly related to cockpit items causing the accident over the last 12 years, and most of them were GA operations accidents. So I don't know how many of you are familiar with the Heinrich Model, but Herbert Heinrich developed this model in the 30s, and he was studied industrial accidents. And his theory came to that for every single industrial accident, so probably back then a fatal accident, there was at least 30 incidents where maybe somebody got hurt or some equipment was damaged, and about 300 close calls. For every one accident, you have this pyramid shape. So if you apply that theory to 19 accidents over 12 years, we have about 1.5 accidents a year, which would also indicate 45 incidents per year. So at some, an incident would be where an accident is defined as some event where the aircraft is damaged substantially, we have substantial damage to airframe, or we have serious injuries of occupants. So an incident may be an event where maybe there was the possibility of an accident, but we didn't sustain enough damage, or there wasn't a serious injury to call it an accident. And of course, the close calls would be something where you didn't have everything come together to cause an accident. So these numbers aren't huge, but they're not insignificant either. So I want to take a look at what kind of guidance do we have out there for pilots and regarding keeping track of cockpit items, managing cockpit items. And there's really not a whole lot out there. The Airplane Flying Handbook has one or two sentences in there, talks about how cabin articles should be checked and tracked in case you enter turbulence, and good housekeeping. Well, that's pretty general, and that's it, 2 sentences. There's 2 SAIBs out on 2 different aircraft that have had some events themselves. One SAIB is on the MU2 where the pilots put a portable antenna on the glare shield, and that antenna moved in such a way that it shorted out the windshield heaters, causing smoke and fire in the cockpit. So they put an SAIB out for that. And then there's an SIB on an American Champion decathlon, where the decathlon retention pin and ring from the emergency door jettison handle lodged between the fuselage elevator and bell crank. I think this happened in a couple events, so they put an SIB out on that, along with probably guidance from the manufacturer to secure those pins. But that, as far as cockpit items causing accidents, cockpit items, you know, moving into areas where it makes it difficult for the pilot to maintain control of the airplane, there's not a lot of guidance there. The next thing I thought about was like, well, what are some of these items in these accidents that are causing, are getting into the control areas, you know, that are causing the accidents? And it's a wide range of things. We've got a personal locator beacon, a jacket, shotgun cartridge, popsicle sticks, magnet, and there's our antenna from my accident, a 10-pound sandbag, screwdriver, nut. So it's a wide range of things. So now we'll take a case study, look at the case studies and look at these accidents and figure out how these items that I just showed you end up causing an accident. So the first case study is a Hughes OH6A from location was in Pantech, Arizona on May 5th, 2003. The pilot was a commercial single-engine land and helo pilot with over 4,000 hours of flight time. This resulted in one serious injury. The circumstances of flight were the helicopter was in cruise flight when the rear door of the helicopter opened, and a flight jacket departed the helicopter. Well, not only did the flight jacket depart the helicopter, it hit the rear tail rotor, and the rear tail rotor separated in flight, causing the crash. So here's a picture of the wreckage of the helicopter, and some distance away was the tail rotor, and here's a picture of the flight jacket all chopped up. So a flight jacket, pretty common item in a cockpit. You know, and I can't believe only a serious injury was a result of this accident, but you know, even a flight jacket needs to be secured in case you hit an upset event or have a door open in flight, which is not too uncommon actually. We get a number of accidents involved door openings in flights. Most of those are caused because the pilot then gets distracted and then loses control of the airplane, not because the door opened itself caused the problem, but that the pilot gets distracted from actually flying the airplane. Another accident here is a Falcon XP light sport from Diboll, Texas on April 14th, 2013. The pilot was a sport pilot with 400 hours of flight time. Circumstances was the pilot was conducting a fast taxi test and inadvertently got airborne. So this pilot's already having a bad day. He's not doing what he expected to be doing. And then if the sandbag they had in the rear seat migrated into a position where it restricted his control stick, and he ended up striking some power lines while attempting to land. And you can see there's the picture of the accident scene. This is a file photo I found, but it's a photo of a 10-pound sandbag, similar to the one that he would have been using. And the reason he had the sandbag was that in this particular aircraft, he placed it on the canard to hold the nose down when he wasn't in the airplane. Otherwise, the aircraft tended to tip up backwards. So he put the sandbag on the canard, and then you know, threw the sandbag in the back seat prior to his flight. And he probably thought, well, I don't have to worry about it. I'm just doing a taxi test. Well, I think, you know, the lesson learned here is anytime you get in that cockpit and you start that engine, be prepared for flight, even if that's not what your intention is. So secure your items, just like you were going to go flying. If you're taxiing, secure your items just like you were going to go flying. Here's another example, extreme air. This happened in Springerville, Arizona, in April 3rd, 2011. Commercial pilot, single-engine land with over 2,000 hours of flight time. He was descending out of 10,500 feet when he heard a noise emanating from the rear seat, and then right after that, he felt a restriction in his flight controls. So he was able to divert to the nearest airport and fly the airplane using the elevator trim. And during the landing, as he pulled the power off, the nose pitched down, and he ended up going off the side of the runway and causing the damage you see in the picture here. When they looked at it, they found his personal locator beacon had migrated into the flight controls there and restricted his elevator movement. So this is the pilot's personal locator beacon that, again, was not secured, and clearly he did not know where it actually was. Here's another example, a Czech sport cruiser. This pilot did me a big favor. I was doing research on this topic, and he has a website where he describes everything that happened in this accident. So this happened in Waukegan, Illinois, on November 14th, 2011. He's a commercial pilot, multi-engine and single-engine land with almost 7,000 hours of flight time. Came away with one minor injury. And the circumstances were during takeoff, the airplane rolled right, and the pilot attempted to correct and end up impacting the right wing. As you can see here, definitely structural damage to the right wing, and landing gear had ripped off. And what he stated, by his own account, was that a magnet that he had been using during maintenance, he had been using a magnet to magnify a tool that he needed to use for his maintenance, and he placed the magnet on the seat, and then forgot about it, and when he took off, this magnet had actually moved and migrated down towards into the flight control areas of the cockpit, and you can see here how it restricted his stick movement. And this is a picture that he provided on his website. Right here is arrow showing the magnet. So even if you're doing your own maintenance, you know, you need to make sure you account for everything. Good tool control. This accident was a Yak 52. Location was Antioch, California on June 18th, 2002. Pilot was an ATP with with 2,600 hours of flight time. It's a fatal accident. The airplane was performing aerobatics when it entered a vertical climb, slowly rolled over, and dived straight into the ground. So this sounds very similar to the accident that I investigated with the Extra 300. Very similar type of circumstances and result. And you can see the wreckage actually looks vaguely similar too. What they found was a screwdriver back in the elevator area, restricting the movement. So, and my last example is the Gulfstream G5. Now this isn't exactly an example of a accident that involved the cockpit items, but it's I think it's a good example of the need to always do a good pre-flight, no matter how familiar you are with the airplane. So this happened in West Palm Beach, Florida, on February 14, 2002. The pilot was an ATP with over 13,000 flight hours. This resulted in 2 minor injuries. And, the flight crew was unable to raise the gear after takeoff, and then ended up experiencing a hard landing. During the landing drove the right main mount up through the wing and breaching the fuel tank. So definitely structural damage to the airplane. What they found was that popsicle sticks had been taped to the landing gear's weight on wheel switch, and this had been done during maintenance, so the maintenance crew could simulate the aircraft being on the ground while it was up on jacks. And the maintenance crew failed to remove the popsicle sticks from the weight on wheel switch, and the flight crew failed to see and identify the popsicle sticks attached to the landing gear during their pre-flight. So when they took off, of course the airplane still thought it was on the ground. They couldn't raise the landing gear, and when they came in for the landing flare, the airplane thought it was on the ground, and as soon as they pulled the power back, the spoilers popped up, reducing lift and causing the hard landing. So even an experienced ATP pilot with over 13,000 hours failed to detect something like this, you know, on an aircraft right out of maintenance. So to summarize, these findings and identify things that we can do as pilots to help minimize and protect against this type of event happening to you. I say you need to account for all items brought into the cockpit, so account for them before you go in the cockpit so that you account for them after you get in the cockpit. Make sure you've got everything with you. If a loose item or unaccounted for item is found, consider it a close call. And the reason why I say that is if we set a mindset as pilots, like that was a close call, you know, that means something to us, kind of cages our brain, and next time we'll be a little bit more vigilant. If you consider a loose item that you didn't know was in the cockpit and you found it, consider that a close call. Also, every time you skip or do an abbreviated pre-flight, you know, say to yourself, hey, this is a close call, I need to go back and do a full pre-flight, because you remember, we're taught from the beginning, the pre-flight is the last chance you're going to have to take a look at your aircraft before you go flying. So don't cut that opportunity short. Ensure your passengers are briefed to secure any loose items of their own or of others, and make sure they take out of the cabin what they brought in with them. And then be extra vigilant after any type of maintenance action, even if you did the maintenance yourself, as we can see in that check score cruiser. I'm sure he didn't intend to leave that magnet there, but failed to check all his items and tools. So that's the summary of the safety alert for cockpit object security. There's 22 safety alerts on our website covering various topics. All of them, very familiar topics to pilots. However, they're topics that you may not think relate to an accident, but these safety alerts show you that vigilance and the safety issues do exist, and gives you things you can do to help prevent those accidents from happening to you. They are located on the NTSB website at www.ntsb.gov. Under the Transportation Safety button, click on that, and you can go directly to the safety alerts. Again, the safety alerts are really simple to read, 2 pages, front and back, or 1 page, front and back. Some good information in there, good review, good refresher. And that's all I have today. Open to any questions? Sure. I'll try to repeat the question before I answer it.
How soon following a general aviation accident is the brief report available to be seen?
Sure. Okay, so the question is basically the timeline for an accident report. What you can expect is after an accident, a preliminary report will be released within 5 working days. That's our normal profile, and that accident will just be a real general summary of what we know at the time. Then the next phase in a general field investigation, the final report, the factual report, will be released first. And that's usually about a year later. And then following the factual report, maybe like a week later, will be the brief report. So the factual and brief get released basically together, and there was nothing usually in between the preliminary report and the factual report. So about a year. You can expect about a year after an accident to see the brief report. And the probable cause is associated with the brief report also.
I have two questions.
Sure.
Does the FAA collaborate with the NTSB during an investigation? Are you there at a dual capacity with your recognizing that you are independent from FAA?
Yes.
Is it a team effort?
Okay, so the question is basically, how does the FAA participate in an NTSB investigation? And it is collaborative. The FAA comes on scene, and we work together they've got certain responsibilities that they have to look at. So they're there in a capacity, the regulatory capacity, to look at what they're responsible for. You know, a lot of times it's airman certification, airport operations, things like that. So they're looking at it from that perspective, and also and they help gather the records. So the NTSB has the lead in the investigation, and the FAA is a party member, and they help get together information. But that investigator that's with the NTSB team, that FAA inspector, excuse me, that's with the NTSB investigation team, cannot use that information that's gathered in the investigation for any enforcement action. He himself is not allowed to do that. It's only as part of the NTSB team, and we're looking for safety issues. Now, once the report's out, then the FAA can look at the report, and someone else, if they want to do more investigation on the regulatory side, they can at that time.
Okay, I have one example, and I'll keep it quick.
Sure.
With the group I'm with, Renter pilot had an off-airport landing.
Mm-hmm.
Both passengers walked away. The pilot felt it was carburetor icing. The NTSB investigation team came to the wreckage recovery building. It was removed into a building.
Sure.
Without contacting the owners, they brought in an expert from Bombardier, and they ran the engine with the prop off at this facility. But in doing so, to accomplish that, they cut ignition wires, cut into the fuel system.
Mm-hmm.
And I know the owner was very aggravated that that kind of action took place without him being contacted. Is that normal?
Yes, that's completely legal. If part of the safety investigation, the NTSB can examine, tear apart, do whatever they need to do to, I'm sorry, I should repeat the question. The question is what can the NTSB safety investigation team you know, take what would appear to be maybe a perfectly good engine and tear it down and do an examination? And yes, it's perfectly legal. We are authorized to do that. If we believe it's part of the investigation, it's critical to the investigation to determine these components' functionality, then yes, we can do that without the owner's authorization. Mm-hmm. Another question? Okay, it's been a pleasure to be here. I'm looking forward to getting out on the line and seeing some airplanes.
Van, what a great presentation.
Thank you.
Thank you very much. Thank you.